Okay, also I want to talk about the sample retrieval, and at the end I have a video premiere. Let's see, sample retrieval. This is where some of the first ideas came out. One of the competitors had this is a puck for retrieval. They had basically a barrier that came and it took it up a elevator shaft like structure. A little bit too complicated, I thought, to be reliable, so I made a few changes. So what you'll see in my pictures is we have a rake, something like a rake, which can pick up a variety of types of samples, and then pulls it into the slide, and the slide tilts up and takes it from there. Let's see. So here's a picture. You can see not too well, but here's the rake portion, and you can see the pink tennis ball there, and it gets pulled up here onto the slide, and then tilted back, and it takes it from there.
This is kitchen table.
Yeah, on kitchen table. My wife put up with this for 3 days. 3 days, so I definitely owe her one.
So we just need to put wheels on the kitchen table.
Yeah.
And afterwards you were kicked out, right?
Okay.
So there's a little duct tape in there.
Yeah, oh yeah, plenty of duct tape, nails, string. I got rid of the pink yarn, I replaced it with normal string. Okay, so here's a side view. The sample again gets pulled in, comes back here, and this is the transport container, and then it gets moved into these separate storage areas. Like I was mentioned earlier, they can't touch each other. If you're on Mars getting samples to bring back, you don't want to cross-contaminate each other. So in this case, there's 3 different samples. We plan to get 10 or 12, so we need a bigger load.
We plan to toss them out as we get the higher scores.
Yeah.
No, we're gonna put them in vacuums with bags.
Yeah, no, that's what I'm doing.
Yeah. And just a little more detail up here, what you can see is the stepper motor. So again, the stepper motor pulls this up, drops in here, and then gets pulled up in the Z direction, and then moved over, and then it gets released.
Wow.
Bagging them wouldn't be a bad idea.
What?
Bagging them wouldn't be a bad idea.
Yeah, that's what we're gonna have to bag.
There's no fine china porcelain or something like that, right?
No, everything's pretty robust.
They don't specify whether it's okay if it's shattered.
No,
Yes,
there
they
actually
do.
is.
You cannot damage
You
it.
cannot
You
damage
actually
the
can't.
samples.
They
No,
could
you
put
can't even
a
put a dent in it.
pillow as one of the samples.
Yeah.
Who knows?
Steve,
Yes.
I have a question.
Yes.
So why are you doing the lifting up and bringing it back linearly rather than the carousel that we saw one
Well,
time?
good question. The carousel, I'm actually a fan of, because you pick that up and then you rotate the carousel underneath it and you just drop it. Very simple. I was starting to make the assumption that we would get a vehicle, from a vendor, for example, and it wouldn't come with a carousel, so we would have to use this. Also, I'm ready with a carousel approach if we decide to make our own. So that and the reason I prefer it is exactly that, because you just pick it up, carousel rotates underneath, and it drops it right back down. Very simple. Now these are kind of early days. About 10 days ago, it was a pile of wood and a bunch of stepper motors on the kitchen table. So now it's ready to get taken off the table. There it is. The first part it got pulled in. It's been brought up.
What's the diameter of the ball?
The tennis ball.
Standard tennis ball.
Oh, it's tennis ball. It's tennis ball.
And with a little bit of luck, oh, there it goes in. That's what we're shooting, right? There's more. There's more.
No, this is lower than that.
Yeah, there's the V6 engine. It knocks a bit.
It could be a little
Any questions?
You got the package on
For the final, Gert has brought his robot. I've got a kind of camera vision thing, and we'll just kind of go over what we're trying to attempt to test this stuff. Victor has like a stereo camera set up, so we can show you a couple pieces, but it's going to be more like a hands-on thing after this. Gertz? So you didn't bring your
Pretty much the same guy that I was showing last time when the floor was showing.
Microphone, I can't hear you. Here's Mike.
Okay. So this is a kind of a small scale version of the rover to test some practical aspects of this challenge. So last time I was showing it was running on BeagleBone Black. So this week I replaced BeagleBone Black with the Jetson board, and it is almost functional. The dynamic slow control doesn't work yet because there are some drivers missing, but that looks like something we can solve. And maybe made some changes to the ball detection since last time, so we can try to see if it helps or not. The lights here are different again, so that will be interesting again.
So again, this is the test bed to kind of test some of our software vision stuff, right? The autonomous then would then be tied to let this run around a room to find the tennis ball instead of kind of seeing it in its field of view and driving to it.
CV also then?
Excuse me?
Yeah. Yeah, we sort of split up the first three critical phases of tasks that we do is search for the sample, detect it, visual photo, feed the sample, in other words, approach it to get within, let's say, a foot or so, and then the pickup guys take over. But that's three really critical steps that we have to do. We can test some of that indoors. In fact, we can test a lot of it indoors, and then we go out into the field to make sure it's really works.
It does, it stops.
Oh, is that what it's supposed
If
to
you
do?
didn't see it, would run over it and
Right.
go to the
Move
wall.
it somewhere else.
It's got to be in the direct path. It's not that smart.
That's where the search comes in.
So,
Well, yeah, it doesn't,
if you watch
because-
some of the videos of the other challenges and the competitions, you'll see the robot
Yeah.
picking it up,
Just
dropping
drive
it,
straight,
running
just
over
drive
it.
straight.
It just can't figure it out. So just the simplest things are hard. All right.
Make sure no one else can
Override.
Yeah.
Make sure no
So.
one else can pick it up.
So, we've got the Pioneer 3 available to us. We've got this, what are we calling this one?
Bowser?
Browser?
Bowser.
Bowser. Patrick's got Scout. Bob has offered another vehicle. I don't know the name of that yet. But to give you an idea, this is basically a mock-up. I don't know if it's going to be the real thing of using a SICK LiDAR that's on loan from the OSRF to basically do distance measurement, and this is independent of anything on the robot, so it can pan any direction it wants, and then it has a digital camera behind it, and this is a front surface mirror that's basically going to do the tilting, so you can see what's going on. So no matter where this looks, the camera picture and the LiDAR kind of sync together. So we can kind of figure out what is the vertical aspect of a picture and what's kind of ground plane, depending on what part of the field we're in. If we're just looking at the totally ground, it will just be the ground. But we can start using that to sense where we're going and what's in front of us, and start using it for localization. If everything works well, I'm trying to get Velodyne to give us a point cloud LiDAR, and that would then be on top. That would then give us a 3D dimension also. That would give us another variation of truth. But this is now the type of stuff we have to carry around. So you can think of the platform, what we're going to be doing, you know, we can kind of shrink it, but the stick's not going to get any smaller, because this is good for 80 meters, you know. The other ones are 30 meters, and what happens is the balance of time to search a smaller area increases. So you now are trading time to cover 80,000 square meters for your search area. So if your search area gets too small, you run out of time. In fact, a lot of the people use like a lawnmower approach. I'm just going to see the 5 meters on either side of what I'm doing, and I have to now run so fast to be able to cover all the territory to see something. They don't even try. They'll never cover the ground and search the entire area. I'm trying to work with people so that we have a good search algorithm, and we're able to basically use this camera independently of what the base is doing to search areas while it's picking up objects, to search for the next object, or to determine areas where I should go look where I haven't seen it before, I haven't searched before. So it's an interesting combination of technologies to bring it into here, where you take high resolution pictures, the LiDAR, the point cloud, fuse it all together and say, there is nothing that I care about in this area. I never have to go back there. I never have to look at this again. All right. Finally, so we're done with that. So, questions? I want to thank you for letting us present. I hope you found it interesting. Again, we've got 7 months before this thing. So we've got 7 months before this, you know, actually have to do it. And we pretty much have gotten to a point where the software and being able to detect the objects, we've solved that problem. So now we're moving on to the search and some of the other designs and figuring out kind of hardware and what type of sensors we need to actually do the challenge. After we do that, it's like the base and what we're going to run this on. And as you can tell, it's not going to be small. January 7th is when we actually have to pay money to join the contest. We have to submit a contract, our biographies, all sorts of information, and a design of what this is supposed to look like. Then in May, a month before the competition, we have to do a video of it actually working. So that's one of your qualifiers to get to this show. We can cut it up in Photoshop or Premiere and make our own video and show it, oh, here's what it did. But when you show up at the competition, it actually has to perform. And that's just a month away after that in June 8th. So that, I want to say thank you. Here's how you can get a hold of me if you have any questions. We're looking for any sort of help, any sort of talent. We want sponsors. We've got big ambitions. Anyone who wants to spend money with us, we'd be happy. Yeah?
How much is the fee?
It's $3,000. You have $3,000 in liability insurance. Yeah?
So, inertial measurement units, allowed, not allowed?
Yes, they're allowed, as long as they don't use magnetic. So a lot of the drift problems you have to figure out.
Gyro, accelerometer, or anything faster than
Right. Yeah. And that's part of our plan. So, kind of as you talk about the design, we've got like a brainstem robot that will be hopefully on Integra using IMU, a small localized LiDAR to keep it from bumping into things nearby. And,
So the reason that they don't allow mag is because there may not be a magnetic field.
that's correct.
If there is no magnetic
The ones they have around gravitation and location of the sun.
Yeah, you can use the sun. Yeah. In fact, Bob presented the idea of a solar compass, so we can keep on top of where we are based on the sun sitting on a piece of glass. Yes,
if you look at the pictures of the different landers and rovers and the NASA photos, you will almost always see some sort of gnomon or sundial or sun compass off to the side of, on probe off to the side. There's those little things sticking up. You can very clearly see the sun shadow. So just about every one of them has it.
So.
Can you drop your own little reference beacon?
Oh yes, it's fairly open on what you can do. There's things that you can't distract in level 2 if you distract your competition with something. So if you're dropping tennis balls and things like that, you probably get tennis ball fire. Things like that. The rules are kind of loose, So the final rule is that samples have to get back to the platform. Nothing really else has to. So you can do all sorts of different things like that. You can throw them at the platform if you care. Things like that.
You can't sit there and mug a robot coming back to you.
Yeah.
The team that you mentioned that had 3 or 4 robots, were there multiple searchers and 1 retriever, or what was their strategy? And
They
what's
all seem to
permitted?
be the same robot. So I think their idea was, go get the pre-shaft sample and the one who gets it comes back. So if you find one object, just go home. They never found any object, so we never saw it. It's very interesting. I recommend watching some of the videos because the commercial one from NASA has kind of like, it's almost like, the funniest home videos, what not to do with a robot, showing them crashing and burning. And then you look at others and it's like, gosh, what were they thinking? And then you're thinking like, this looks really cool. It's got, a very expensive arm. It's got a very, robust chassis, and it doesn't even get off the platform.
Rockets?
What?
Rockets?
They do allow any type of rocket that doesn't have any dangerous fuel. So that. Yes, anything that flies has to be tethered to the thing, and you have basically a 4-meter height limitation. So you can't go very high.
So you can't get high enough to use visual recognition to figure out what direction you're going.
You can get high, on a little robot, 12 feet above it, pretty high.
Yeah, but you kind of want you want to get high enough to be able to match to the satellite.
Right. Yeah. No, you're not going to be able to.
You can't have like a separate little orbiter.
The actual object has to start and fit within a platform that's basically just under 5 feet, or actually 6 feet, just under 6 feet by 6 feet by 6 feet.
What about weight?
80 kilograms. So it has to be somewhat light. So actually, weight's going to be kind of one of our considerations here. We'll be spending $700 on a battery because it weighs less than $200 battery.
Have you looked at hierarchical classifiers for the vision? So do the kind of blob matching like was mentioned, and then once you have that, kind of zoom in further, and then try to do more detailed things. Have you explored that at all yet?
Yeah. Well, that's what we're evolving to.
The problem is at the start, we're already at full zoom.
Yeah.
Oh, okay.
And we're only the sample's taking up maybe 1/1000th of the area of the picture.
So, but again, your logic is find me samples, right? And we assume this is the only sample at level 1 in the area. So I think the sample is this, right? If not, drive me someplace and I'll start looking again. So as you get a sample and you say, oh, I think this is a possible sample, and you start driving towards it, then you get more pictures. And you'll at some point in time say, oh, that is definitely a sample, because it's now this big in your picture.
Not the one you can tell that I've checked that one already. Don't go back there.
Yes.
Okay.
Yeah, that's all
They
part of
also
mapping.
claim that they won't be. We're going to be fairly careful about not having any significant distractors on the field. So they're not going to deliberately put little fluffs of Kleenex, balls of Kleenex or anything. And if anything comes on,
Styrofoam
like
plastic
try to
cups.
get it off.
Okay.
Yeah. Yes.
Question about the terrain. Is it going to be varied? Water, grass, dirt, leaves?
If we find the water, we're in trouble.
Yeah, we're in trouble. Yeah, it's pretty much what do they call it? American Disability Accessible Terrain.
How about the weather?
The weather is you could run in the rain. Yeah, you
That
could
would
run
be
in the
rough.
rain. So you definitely have weather. I don't think they said lightning.
Where
Stop
is the
everything.
contest?
It's in Massachusetts. Worcester. Massachusetts.
Have you done any observation or sample detection runs like in the weather we've been having lately, or is it all going to be ice on?
I've done it in totally overcast and partial cloudy and full sun, but not in the rain, because I don't own the camera.
Yeah. So,
What's the budget?
Proof, just water resistant.
what's the budget? It depends on what the team can come together or what we can self-finance. So right now we don't have. We're expecting to spend about $30,000. Probably, as a group,
Any
on little
sponsors?
pieces, and to get this thing together. The hardest part is trying to figure out like a vehicle. We'd rather buy one or rent one because trying to build a vehicle is just, it's energy that we should do on software. So.
Are there any last questions? Let's do one more.
I didn't quite hear you, why the mirror that pulling up, you move the mirror?
Yeah. Yeah, and the idea is that, this is just a sample, but, you can get a bigger mirror and get it way up.
Is the LiDAR pointing at the mirror?
No, the LiDAR is just going to be in the front. Yeah. So the idea is to use the camera to give you a down, and then the LiDAR would then have things showing up, and then because it's closer, you could say, okay, that's something going vertical. And so I could then take that out of my matching of the template. I could actually make a template that say, below this line, or above this line, don't look for anything. All right.
I'd like to thank Greg very much.
Oh, yeah.
And concluding the organized portion of the meeting. I'd like to invite everybody to show up in January. We do not have a meeting in December because the last Wednesday of the month is always between Christmas and New Year's, and lots of people have other things to do. So our next meeting will be in January, the last Wednesday of the month. Please go to our website to figure out where it is. It's likely to be here, but that hasn't been officially approved yet. Okay, and one last thing with the new members of the Executive Council, we want to do a little rendezvous and talk about our plans for next year. So if I could get everybody to show up in about 10 minutes, we'll talk through the Executive Council agenda. So thank you very much, and I'll be kicking everybody out at 10. Thank you. Oh, last thing, badges, please put them in the box as you leave, okay? Thank you. Bye.